In this final video segment, we're going to see Python in action. This will be a step-by-step that shows you how you can interact with the Python interpreter. The Python interpreter is going to be one way that we can interact with Python. We've already seen that a file is a much more efficient way of creating a larger Python program or one that we want to distribute to other people, especially one that we maybe want to turn in for some points in this course. However, today we're just going to use the Python interpreter so that we can immediately see how Python reacts to individual instructions that we give it. When you're viewing the demo, realize that you're not expected to know or understand anything about how Python's working. Just sit back and enjoy the show as we think about how Python reacts to instructions that we're giving it. We'll learn more about every instruction covered in the demo throughout the semester. We're just seeing some of the things that are possible. First, let's look at how we launch the Python program. On my computer, I need to go to the Applications area and then navigate to Python 3.8. Below that, I see the idle icon, and that's what I click on to start idle. That begins the Python interpreter. Let me resize this window so that we'll be able to see everything that I'm typing more easily. So we have the Python interpreter here. And again, because we're just trying some things out and we're not trying to create software that we distribute or share with others, we're just going to type immediately in the Python interpreter window. We'll see that Python knows lots of things. For example, we can type in any number and Python will tell us, hey, that's the number. So if I type in a 5, Python responds with, hey, you typed the number 5. Python also knows how to carry out arithmetic operations like adding 3 plus 1. It gives us the answer 4. And it knows how to carry out all the arithmetic instructions. So it can do more than just addition. It can do things like multiplication, 10 times 5. Notice that it uses the asterisk instead of the multiplication symbol that you might be used to. But it still gives the answer that you'd expect, 50. Python also has some fancy arithmetic operations, things that you might not be familiar with from your regular math classes. We'll learn more about all the arithmetic instructions in a future week. In addition to just carrying out arithmetic instructions and recognizing numbers, Python allows us to store data in memory so that we can retrieve it later. For example, if I wanted to keep track of the number of students in this course, I could create a variable called numStudents and tell Python to store the value 27 in there. Python would be happy to oblige. I can also store decimal values like a price of 10.99 or a name. Python's happy to store anything that we want it to store. We can recall the data that's stored at any time. For example, we could print out the value of the name and it'll tell us Dr. A remembers that that's what's associated with that particular storage location. We can also print out the number of students and it'll tell us 27. In addition to the data value that's stored inside a storage location, Python can tell us the kind of information that's stored as well. So for example, if we want to know what type of information is stored in the variable price, Python will tell us that's a float or decimal value. If we want to know what kind of information stored in the number of students variable, it'll tell us it's an integer or a whole number. And if we want to know what's the type of the name, it'll tell us that's a string or a sequence of characters. We've seen that Python can display information in a single variable or storage location. It can also print that in conjunction with other data like a label. So we can print things like hello and then a name, and it'll tell us, hello, Dr. A. So it prints out the information we provided in double quotes and then also appends the information that's stored inside that name location. We can put together as many pieces of information as we want. For example, we can print hello, name, your total is, and Python will print, hello, Dr. A, your total is 10.99. It's retrieving the information from both of those storage locations and adding the labels that we provided between them. Python can also make comparisons between information. For example, it knows whether price is greater than or less than the number of students. remember that price is 10.99 and number of students is 27. What do you think the answer will be when we type in price less than num students? Python tells us, hey, that's true because 10.99 is less than 27. If we change the value of price to be, say, 31, and then we compared price to the number of students, Python would tell us, hey, that's false. 31's not less than 27. This might seem trivial and not very useful, but actually, comparisons like these are really important in software. Whether you're trying to see whether somebody's password matches their expected password for their account, or whether you're testing to see whether you've reached a particular pressure so that you can accelerate a motor in a space shuttle, you need to make these kinds of comparisons in software. And so these kind of operations in Python are really important. In addition to just knowing whether these values are true or false, Python allows us to make decisions in our program based on the comparison of values. So we can say things like, if the price is less than the number of students, print price is less. Otherwise, print price is more. What do you think the answer is going to be? Do you think it's going to be more or less? Python tells us, hey, the price is more. And it knows that because it made the comparison between the price, 31, and the number of students, 27. And because it's not less than the number of students, it prints the else operation or the else statement component and prints price is more. If we changed the value of price to be 5 and then re-executed that same instruction, remember we have to like retype it if we're using the interpreter. What do you think is going to happen after we execute it? If you guess that now it'll print less, you were right, because 5 is less than 27. So Python has mechanisms that allow us to make decisions in software to do one action or another. Python also allows us to repeat instructions using a repetition structure. We can do things like, if the price is less than 20, print the value of the price, and then add a 2 to it. So we're telling Python that we want to repeat these 2 individual instructions over and over again until the price becomes greater than or equal to 20. So we start out with the value 5, then it's 7, 9, 11, 13, 15, 17, 19. Once it's 19, we add 2 to it, and the new value would be 21, which makes it greater than the value 20. So we stop the repetition at that point. Finally, Python allows us to define named sections of code that are reusable. We can do this by creating a function. So I could do something like process a price while the price is less than, we'll do 30, since it's already 20. Print the price and then add 2 to it again. So notice that when I created this function, nothing happened yet, and that's because I didn't tell it to execute it. First, let's print the value of price just so we know what we're starting with. So currently, price has the value 21. That's right, because that's 19 plus 2. That was the largest value we had in the last repetition statement. So now if we tell Python we want to run our function process price and pass in the value of price, it'll run it for 21, 23, 24, 27, or sorry, 21, 23, 25, 27, 29, and then it'll add 2 to the 29, that makes it 31, and it's no longer less than 30. This is a really nice way to make code that can be used over and over again. We can use this with any value at all, so we could run it with a value 10, and it'll repeat for that value, or we could run it with the number of students in our course. Whoops. You have to spell it right. And it'll run it for 27, 29, and then it'll be 31, which will make it larger than the 30. So these are just some examples of things that you can do in Python. Again, we'll be learning about all of these all semester long. We'll be learning about how to use data like numbers or character strings. We'll be learning about how to store values and variables, how to display information to the display screen using the print command. We'll be talking about data types. We'll be learning about different ways of comparing data and taking action based on comparisons using decision statements and also repetition statements. And at the end of the semester, we'll learn how to create our own functions so that we have named components that we can use over and over again on different data values in software. Please realize that whenever you're creating computer software, it's really easy to make typos. So it's not unusual for you or me to get errors like this that tell us that Python isn't sure what we're trying to do because we've typed something wrong. If that ever happens, just take a step back, look at what you typed, and then try to identify the missing component and then try to re-execute. I hope you're really looking forward to learning more about Python throughout this semester.